A collection of independent computers that appears to its users as a single coherent system. This figure, a distributive system organized as middleware. The middleware layer extends over multiple machines, and it offers each application the same interface.
Characteristic of distributed system. 1. One of the important characteristics is that differences between the various computers and the ways in which they communicate are mostly hidden from users. 2. Users and application can interact with a distributed system in a consistent and uniform way, regardless of where and when interaction take place. Goals. A distributed system should easily accessible. Hide the fact that resources are distributed across a network. Distribution transparency. Open, scalable.
Making resources accessible. The main goal of distributive system is to make it easy for the users to access remote resources and to share them in a controlled and efficient way. Connecting users and resources also makes it easier to collaborate and exchange information. Distribution transparency. A distributive system that is able to present itself to users and applications as if it were only a single computer system is said to be transparent. In this figure, we can see the different forms of transparency in distributive system. They are access, location, migration, relocation, replication, concurrency, and failure, of which we will discuss their description. Openness, degree to which new resource sharing services can be added and made available to the user. Interoperability, different manufacturers can coexist and work together. Portability, System A can be executed without modification on a different distributive system B. Extensible. In an extensible system, it should be relatively easy to add parts that run on a different OS and even to prepare or replace an entire file system. Scalability. One of the most important design goals for developers of distributive systems can be measured along three different dimensions. One, with respect to its size, means we can easily add, move users and resources the system. Geographically scalable system, in which mean users and resources may lie far apart. Administrative scalable means it can still be easy to manage if it spans many independent administrative organizations. In this figure, there are examples of scalability limitations. They are centralized service, centralized data, and centralized algorithm.
Scalability problems. Characteristics of decentralized algorithms. No machine has complete information about the system state. Machines make decisions based only on local information. Failure of one machine does not ruin the algorithm. There is no implicit assumption that a global clock exists.
In this figure, we can see the difference between letting a server, or B, a client PC, form as they are being filed. Distribution. It involves taking a component, splitting into somehow, and subsequently spreading those parts across the system. For example, is DNS. The DNS namespace is hierarchically organized into three domains, which are divided into non-overlapping zones. The names in each zones are handled by a single name server.
Pitfalls when developing distributed system. False assumptions made by the first-time developer. The network is reliable. The network is secure. The network is homogeneous. The topology does not change. Latency is zero. Bandwidth is infinite. Transport cost is zero. There is one administrator. Distributed system challenges. Lack of global state information. Different nodes have different view of system. What are the contents of file A? How many jobs are running on node X? Which nodes are currently part of the system? C delays, different ordering of messages, lost messages, network partitions. Tensions with goal of single coherent system. Handling slow, failed, and misbehaving nodes. How do you avoid slow nodes? How do you get back data or work from failed node? When nodes disagree, how do you know who is wrong? Tension with goal of available and reliable. When is it okay to have some centralized components? Simplify states management, but single point of failure and performance bottleneck. Benefit of distributed systems. Great price performance. Leverage commodity components, nodes, and networks. Use many of them. Incremental scalability. Can add percent new nodes. or disk or memory to improve performance percent. Improve availability. Continue operating when some nodes stop working. Improve reliability. Deliver correct results when some nodes misbehave. Corrupt data. Allow geographically distributed individuals to share data or cooperate.
Types of distributive systems. Distributive computing system, cluster computing or grid computing, distributive information systems, transaction processing systems, or enterprise application integration, distributive pervasive system, home systems, electronic health systems, sensor network. Cluster computing systems is used to parallel program in which a single program is run in parallel or multiple machines. In this figure, we can see the example of cluster computing system. Grid computer systems. A characteristic features of cluster computing is its homogeneity. homogeneity. A key issue in grid computing system is that resources from different organizations are brought together to allow the collaboration of a group of multiple or institutions. Such a collaboration is realized in the form of visual organization. In this figure, we can see a layered architecture for grid computing systems. Grid computing system architecture. Fabric layer. It is the lowest layer. Provide interface to local resources at a specific site. Connectivity layer. Communication protocols for supporting grid transaction that span the usage of multiple resources. Grid computing system resource layer manage a single resource. It uses the functions provided by the connectivity layers and calls directly the interfaces made available by the fabric layer, responsible for access control and hence rely on the authentication performed as part of the connectivity layer. Collective layer handles access to multiple resources, consists of services for resource discovery, allocation, and scheduling of tasks onto multiple resources, data replication, and so on. Unlike the connectivity and resource layer, which consists of a relatively small standard collection of protocols, the collective layer may consist of many different protocols for many purposes. Application layer consists of applications and operate within a virtual organization in which make use of the grid computing environment. The collective connectivity and resource layer form the heart of the grid middleware layer. These layers jointly provide access to and management of resources that are potentially dispersed across multiple sites. Advantages. Inherently distributed applications like distributed database, worldwide airline reservation, banking system, information sharing among distributed users, like groupware, resources sharing, like sharing database or expensive hardware, and controlling mode, laboratory device. Better cost performance, ratio performance, effective for coarse grain or embarrassingly parallel application, reliability, non-stopping availability, scalability, loosely coupled connection and hot plug-in, flexibility. Challenges, problems, disadvantages. Application distribution, heterogeneity, security, scalability, failure handling or reliability, concurrency, transparency, and management. Advantages of distributed systems over independent PCs. Data sharing allow many users to access to a common database. Resource sharing. Expensive peripherals like color printers. Communication. Enhance human-to-human communication like email and chat. Flexibility. Spread the workload over the available machine. Advantages of distributed system over centralized system. Economics. A collection of microprocessors offer a better price or performance than mainframes. Low price performance ratio. Cost-effective way to increase computing power. Speed. A distributed system may have not more total computer power than mainframe, but it enhances performance through load distributing. Inherent distribution. Some applications are inherently distributed, like in a supermarket chain. Reliability. If one machine crashes, the system as a whole can still survive. Higher availability and improved reliability. Incremental growth. Computing power can be added in small increments. Modular expandability. Another driving force, the existence of large number of personal computers, the need for people to collaborate and share information.